All right, finally, let's take a look at code refactoring. So take the practice called deduplication, and we talked about it in a prior video. There's actually two main methods that you might want to use. There's probably a million methods, but here's method one. X equals a list with redundant values, elements. There's redundant 34s. And then what we can do is step one, we transform that data structure that is a list now into a set. And the set algorithm removes any redundant numbers, and then we can place it back into a list. And if we print X, we get the fact that it's now removed the redundant 34, and we can verify that it is back to being a type list. As we can see, it's called a class right here because essentially list, there is a class called list, and when we create lists, we actually create an object from that set. And because list is a preset object, we can actually have various methods available to us. And set, of course, is an object. And just by transforming it from a list to a set, we have removed the redundancies, as you can see here. There is a second method that we can look at. And here is the original list with the redundant 34s. Now in this method, we create a new list and we call it new X, and then we utilize a for loop to increment over each element in the list. And we say for I in X, if I is not in new X, then we're going to append I into new X. In the case of the 3418, there was no reason not to not append it, but in 34, in the case of 34, it was in new X, so it did not append it, but that is redundant. That's, or shall I say it's implied. We don't have to say if else don't append it. That would be basically a waste. So we have to imply that there's an else and a missing else in here, and we prove it. Print X is equal to the redundant 4s, and print new X, we remove the redundant 34s. Now we're going to talk about different inputs yield the same process, but that means they may also give off different outputs based on the inputs. So because the process or algorithm or coding stayed the same, even though you had different outputs, that's called polymorphism, because the output might be different based on the differing inputs, but it's the same process. For example, X equals input enter X. So I enter X and I enter 4, and then we go through the process of concatenation. Now we've seen this before. We know that it's going to be actually 44 because it's treated as a string. Now when X equals enter X and we enter foobar or a phrase and we say concatenate the phrase, this makes sense because it's basically the string doubled or repeated or replicated. However, what if we wanted the process to treat the two different types of inputs differently? What if we wanted the phrase or the programming to be smart enough to know and understand that, hey, if this is a 4 and we want to add 4 plus 4, we want 8. We don't want 44. Well, we can think back and say, wait a second, X is a string, so we'll say, because we know it's a type string through the type global function, and it's a class string, but what other string methods are there? So we'll say X dot and then the tab button, double tap it, and we see there is a method out there referring to isDigit. So in other words, it can detect whether or not, even though it's a string, it can detect whether or not that character is in fact a digit. So for example, we have X is equal to the string 3. However, we can look at one of the possible methods is isDigit. So we can say isDigit, and the answer is true. What the strategy we're going to utilize is ask for input, and if input is digital is true, then we're going to treat it like a number. If not, meaning if it isn't a digit, then we will treat it like a string. That's exactly what we are doing here. We created this program called PolyM, and we're catting it out. We are streaming it so we can see what's inside polym.py, and we actually ask for input, enter a character. Now, if it is a number, meaning if num1 is digit equals true, and notice it's a double equals because we're comparing it, I should say. So in other words, if input is digital is true, that's exactly what we're saying here, equals true. So we're saying if num is digit is the logical equivalent of true, then we're saying if num is digit, then we're saying x equals int num1 plus int num1. However, and then print x. However, if not, meaning that we're presuming it is a string, we will just simply concatenate it. Let's see what this looks like from the user perspective. We're going to run it, Python 3, enter a character, and we'll say 4, and it does yield 8. However, if we say R, it simply concatenates it. All right, for those of you that were curious about something, why did I appear to have two if, then, or if conditionals in a row? Remember, I had if num1 is digit equals true, then there was another one. I just simply removed the second one, and so here is the finished program right here. Again, there's only one if entry there. So let me go ahead and quit this. Let's again run Python 3 polym.py, enter a character. We'll say 8. 8 plus 8 is 16, and run it again with the character q, and q equals the concatenation of q. So this is an example where I just simply adjusted the code, and now it runs possibly even more smooth. Okay, here are some tips for doing the homework and assignments for this course. Tip number 1, and most importantly, is do not use classes unless explicitly asked. As I told you before in week 1, other languages force you to use classes, but as you can see, simply using tuples, lists, strings, dictionaries will get you through most of the assignments in this course. And even, for example, the phrase h equals hello, even if you write h equals hello in idle, it can still be considered object-oriented programming because, for example, the object type is a string, and string, of course, is an object type. And when you have these pre-baked object types in Python, it comes already with pre-formed methods for that object. Here is an example assignment. Create a program that asks the user to create a password that is at least n elements long and has at least one special character. So how do I go about solving this? You say to yourself, wait a second, my instructor asked me to use a while loop or for loop or a if-then statement. No, so I can do it however way I want to. If I look at Google, it's probably going to give me 100 million ways of doing it. A lot of times when you look at Google, you're going to show past answers to a program like this where the author used classes and it used instantation and everything. But since this is 2024, we don't really have to do that syntax. We can just use a for loop or array or list at our disposal to get the right answer. So a polymorphism says there's more than one way to get to an answer. So here is kind of like you're thinking, all right, well, in idle, for example, we know how to ask the user to create a password. So we can say user enters password, and then we want to check if it's at least that it's the length. So check length, because we said it asks the user to create a password that is at least n elements long and has one special character. So the question is, how do we check the length? And then in your notes you could say the len function, the lenf. Remember, we can take a string and get the length of it, take a string or list or tuple or anything, and we could get the len length of it through the function len. And then we'll check to see if at least one character is a special character. So maybe we can have a list or string of special characters, and maybe we could check in this string of characters, maybe it would actually be true. So I advise us to start in idle, So you say something like X equals input. We'll say P equals input, enter a password. Okay, that's simple enough. And we'll say RTWE23. And how can we check the length? So we can say len of P is a great way for us to check the length of the password. So what would happen if we created a file that said if P greater than, so first we have to create a log. We'll say password log equals an empty list right here. So if len of P greater than 4, because it says it needs to be at least, I believe, 5 characters. Let's see. Oh, okay. Let's say in this scenario, we need it to be more than 4 characters. So if it's greater than 4 characters, we can say that password log dot append, and we could say it'll append P. Okay, and let's take a look at that password log. Okay, and it was able to append that password because it was more than 4 characters. But wait a second, what else did it say? It says and has at least 1 special character. So special characters equals a string. In this particular case, we could say P in special character, and that's going to be false. So we can have it go through 2 tests, and thankfully we came up with something already, and this takes care of the first issue, and so we ensure password is compliant, and we can use a while loop here, and here's the password log. And we're making sure that the password is at least 4 characters. So we're saying if I in choice, for I in choice, if len of choice is less than 5, choice is no. Okay. And for P in choice, we'll say if P is in this string of special characters, we'll say append the choice.